that always a student talked about Taylor Winfield, Prokop, and a couple of those that are working there. And also, we don't have Bob Caven here yet. Bob Caven is one of the faculty who has worked with me throughout the semester, working with the students as a partner faculty. He made donations to this conference. Please give a big round of applause to the donors. And I would like to give you an introduction of what has happened throughout the term here until now. This is good to know that. All the students, with no exception, in electrical engineering department, they have to team up and form a group of 3 or 4 to design a product which comes from their ideas, and then go through the design process until they complete the design, make the prototype, and prove that it's working. This is what you see here. All projects, no exception, are working. And all the students, they have gone through that process. They bring their ideas to me. I never reject the idea, but I communicate with them until we compromise in the principles, until we both, from my side and the group side, we realize that meets the criteria for capsule design. As soon as we agreed upon, then I changed my position to a supervisor and the originals. Then they start to write the plan. They complete their initial plan and bring it to us for approval, and they continue. Every 2-3 weeks, they had to give a progress report. There was no exception. And Bob Caven is not here. He worked with me throughout the semester also. He was very instrumental working with the students. We were interacting day by day, watching. I have been witness of hard work that these students did throughout the semester. I would like to thank you, all of you, for doing that. At this moment here, I would like to introduce our speaker, Mr. Mike Prokop. I had the privilege last summer to visit Taylor Winfield. And I got into the lobby, and talking to the secretary, he said, wait, someone is going to call you in. And I was sitting waiting to see who is that someone coming out of that glass door. And suddenly I saw someone came out of the glass door, came to me, and hello, he shook hands and introduced himself. He said, I'm Mike. I was a student 25 years ago. I forgot his face. And then we went back to his office and we talked. We went through the plant and back to his office. I believe for a couple of hours we were chatting and talking about the memories and the time that he said, I did not remember that. He was sitting in the corner of the classroom and listening. And he told me the story of that day, but I don't want to repeat it. However, this is my privilege, and it is my honor to introduce to you Mike Prokop from Taylor Winfield. Please welcome Mike.
Yes, thank you, Dr. Jamali. Not sure where to stay. I just want to move this out of the way. Yeah, I'll finish that story as this goes on. He chewed into 10 minutes of my time, so I'm going to have to go really fast.
No, you don't have to. I can be asked.
Okay, we can be a little bit flexible. Okay, great. Yes, once again, I am Mike Prokop with Taylor Winfield Technologies, the innovation leader. That's product development, R&D. They call me a leader, so they don't have to pay me any extra beyond what I normally do as the chief electrical engineer. So in that role, I've got 10 electrical engineers in the group, 2 interns, all YSU grads, all very sharp, and they make my job easy. They're great guys. So quickly, I can go through this. My academic background, yes, 1989, YSU. Is that where you guys sat? And I went on to get my master's at Georgia Tech in 94, and I know that might be kind of bad form, talking about a different school while you're keynote speaker for your previous school, but point of note is the electrical engineering program at Georgia Tech is ranked number 3 in the country, and the point there is I did not struggle at all based on the foundation that I got at Youngstown State. So you guys are in a good place. You're getting very good college education. Real quick, because there's other things I got to talk about. Just show that I got some street cred. Started nuclear power right out of college. Did a stint doing the weapons. Can't talk too much about that. That treason thing is still kind of it's a little bit of a threat. Take it very seriously. Naval reactors. That was a job where we made the power plants for the nuclear subs and carriers. So as an automation engineer, I programmed the robots that actually clad the ID of the reactor vessel, steam generator, and pressurizer. So there's 6 or 7 subs and carriers out there in service that have some of my programming in it. Facilities, probably the most boring job I've ever had. It was anything from 69,000 volt systems down to the 480 volt, doing preventive maintenance on breakers and transformers, substations. It has to be done, but by somebody else. Manufacturing, that was a good exposure to automation and controls with PLCs and drives. There's a big market out there for electrical engineers in this area. I would say at least half of the jobs, everything runs on controls and automation, and this is things that you guys could be doing. Systems integration, had my own business for a couple years where I did software engineer and just basically integrated controls, which is where I met Taylor Winfield, which is now my current role now is in management, and I'd say by far that's the most challenging and responsible job that I've had ever since. You know, it's a good company. It's been around since 1882. The people are great. I think we have 90-some employees. I think almost 60 of them are YSU grads, or they're engineers. 37 are YSU grads. So it's a great place to be. Why I'm here is to continue Dr. Jalali's story. So yes, there we were in my office, and I remembered a field theory lab that we were supposed to have. And I came in, and he says, we're not going to have a lab today. This is E706. I think it goes by another course code right now. We're not going to have a lab. We're going to talk about what you guys are going to do in a year as aspiring engineers. And I still remember that. It made a big impact. He went down the list of, do you want a high-pressure job? Do you want an easy job? Do you want a lot of stress? Do you want a long commute? He basically laid out every kind of potential opportunity that you would be able to choose from as an engineer. And it made me think. Of course, everybody at that point, they just want a job. I don't care where it is or what I do. I just want a job, and then I'll take it from there. So while he was in my office, I reminded him of that. He said, well, would you be interested in doing that? So maybe about a month ago, came by to talk to the junior class, and it gave them kind of that in the career development, things that they could see, things that they could expect, things they should be aware of. And I think at that point, after he saw that I was chief entertainment, he asked me to do this right here. So he's asked, do you mind speaking at this conference? I said, not at all. How long do I have to speak? He said 30, maybe 40 minutes. I said, okay, I can easily talk about that, 30, 40 minutes. What do you want me to talk about? He says, I'm not sure. I'm going to need a little bit more to go on than that. So I walked to the WIC deck. I don't know if they still call it that. Okay, and I'm thinking, 25 years ago, this guy gave me difficult assignments. I'm driving out, navigating through the deck. This guy gave me difficult assignments, and he is 25 years later still giving me difficult assignments, and I'm not even in his class anymore. So I'm here. He did ask me, however, to talk about how things relate. Okay, it's very important. We have members of industry here, academia, and obviously you students. They all do relate. So how best to do this in a Venn diagram. So there's a practical application for a statistical principle in the Venn diagram. So we've got some things. We've got industry. We've got the students, that's you. We've got academia, and I have multi-areas of intersection. There's a relationship between each and every one of these, and I'll go through. I got some talking points about how each of them do it. Each area is different. It's different, but they still are very dependent on one another. And if you notice, the smallest area of intersection in the middle is the smallest, and actually that needs to be the biggest, because as you progress and you go down this path, the students are going to have to rely on academia. They're going to need industry for a job. Industry is going to need academia to provide students, and it's just a vicious circle. So industry's needs. As for electrical engineers, there's no clipboards anymore. The days of people going out into manufacturing and writing things down with a clipboard and counting parts made, any kind of production control. It's not that way anymore. Everything is automated. So you've got a machine that makes torque converters. Okay, connected to the PLC or the processor in there is an Ethernet card that talks to the plant's level 2 system. The customer's computer system knows exactly how many parts were made in that shift, how the downtime that was on there, the quality of the parts, if they have any of that kind of measurements. This is something that is right up your alley. Yes, so they get machine performance. Production scheduling is another thing. They don't have production schedules anymore where it comes down on a piece of paper and guys print it out of the printer. It's all printed down or directly, digitally, right to the operator's control station. There's a problem. All right, you guys are getting into an industry that's, we have a society that's enamored with gadgets. We didn't have cell phones, your age, payphones. And there's a big market for devices out there that are manufactured, designed by electrical engineers. FabTech is a trade show that they hold every year. Basically, it's a conference convention where vendors can showcase their products. You got two different vendors. They make the same kind of machine. It does the same thing. Brand A, brand B. The difference is the coolness factor. So this is back to the gadgets, where now a lot of these machines are now run by tablets. So we've seen machines that we can control in Michigan from a tablet in our office. And the coolness factor is there. Automation in manufacturing, obviously that's what I've been talking about. Manpower. It's sad to say that as you automate things, you kind of whittle down the manpower in the production facility. That's not to say that we're doing away with people, because you still need operators to load the machines and things like that. You also need maintenance guys to service the machines that you guys are designing. So at the end of the day, you don't lose a head count, but it's just that they're given their manpower to do other things. Software, firmware, hardware, that's everything that you guys are doing. It's Arduino, that wasn't even a pipe dream when I was sitting where you are. So those kind of products are still being developed as well. So it doesn't have to be the end result product. It could be the vehicle. Who's doing the field programmable gate arrays? You guys, yes. There you go. It's a chip with how many? Thousands of gates. So, and we still run on electricity as a country, so you're not going to get around that. So you guys probably, of all the different fields in engineering, I think that your job opportunity, your prospects are much more greater than any other discipline. All right, on the other side, academia's needs. They need tuition. Without a student, they don't really have a job. There's nobody to teach. So they have to be continually trying to draw students into their campus, looking for industries with funding like we're doing now. STEM Advisory Board is something there was no STEM college when I was here. This is something that's really growing and developed. There's the STEM Advisory Board. I'm not sure why Taylor Winfield Technologies is not on the STEM Advisory Board. Not my call. Accreditation, academia does have to make sure that they're accredited. They've got to keep the bar raised high. They've got to provide you guys with a theory and a technical foundation. Back to my grad school story example. They were successful in doing that. I got to hurry. Personal and professional development. I definitely saw that when I don't know if you guys remember, I came to your lab a couple weeks ago. I was really impressed. I was blown away. You guys got it going on. We didn't have this. We didn't do this 25 years ago. you guys are working as a team. You're working on really cool, innovative, technical things, and you're this close to being in industry. The only difference is you're not getting paid for doing what you're doing right now. Okay, so Capstone, just talked about that. Success stories. Universities want to demonstrate success stories. This is something that academia has to do. You always want to promote your own. Notoriety, along the same lines. Yes, I hinted at that. It's not the same wide shoe. It's completely different. You know, my capstone project was basically a book report and job placement. Most of you guys have jobs. Like when I was there was two graduating seniors that had jobs. So the university is doing much more in terms of getting you guys out and on your feet. Students' needs. You can guess the first one, right? You want a job, right? Okay. You're going to need a strong technical background. I believe you're getting that here. Bachelor of Engineering, I don't know if you guys know this, that's not a real common degree. It's usually a Bachelor of Science, and I think that there's maybe one or two other universities that offer Bachelors of Engineering. And basically, it's an application of theory. So you guys, I know, get a lot of theory. It's basically a practical application of that theory rather than being able to use all Maxwell's equations, which some people still do. You're going to need the interpersonal skills, which was clearly demonstrated when you guys, were showing me your projects a couple of weeks ago. It's very important to have interpersonal skills. Trust me, this is one of the endeavors that we are always trying to maintain in industry is the interpersonal skills, how you work with each other, the team concept. Creative thinking, I can't stress that enough. It's okay to think outside of the box. And actually, I think it's mandatory to think outside of the box. Get the right answers. You want to make sure that your work is accurate and correct. And it's really important to have confidence. So, oh, who's nervous here? Come on. Yeah, like, oh, come on, the rest of you are liars. I'm trying to keep it relaxed. Actually, I went to sleep last night thinking, I've never been a keynote speaker. And, this is a pretty good feeling because I don't have to defend a thesis or a white paper that I've written, and I'm going to get grilled by people who want to make me maybe shoot some holes in my project. I really got nothing to say. You can probably see that right now. It's a good feeling to just kind of get things rolling. I just kind of want to just maybe lay out a little element of relaxation for those of you that meeting deadlines. Who was up till 3 in the morning? Almost all of you guys. So yes, that's important. Yeah, that Dennis Hatter. Yeah, he says if you approach every project like it's due tomorrow, you will never have the sensation that it's due tomorrow. So that's key. Budget constraints. You guys only have 300 to work with. 300,000 is a little bit more wiggle room. You'll learn that when you get out there, some of the people in industry say work's correct. Done on time, under budget, pick 2. Yeah, that's the truth of it, but please at least strive for all 3. All right, a little bit on career development. I gotta go in on this. All right, what do you guys want to do? They say the typical engineer changes jobs 3 to 5 times in their career. I'm on 6 or 7. Your current job may just be a stepping stone. If you just want to get a job and get out there. If you really prefer digital signal processing and you find that you're working with transformers and breakers and circuit design, there's a way that you can get over there. But learn everything that you possibly can in your current assignment, even if it's not your cool dream job. Seek out what interests you along the same lines. If there's something that is really of interest to you, it's not really your project, well, maybe you can kind of, look over your buddy's shoulder or just kind of learn on the side the things that are going on with a project that might not even be yours. Electrical engineers are in demand. I think Dr. Jolly was saying that there is actually a shortage of electrical engineers right now. So that's a good thing. And not everything is electrical. Took me about a week to realize that on my first job. It's not. There's not a fine line between electrical engineers and what a mechanical engineer is going to do. If you're doing robotics, there's definitely materials engineering, if you're going to be doing any kind of welding, there's an overlap in that. The mechanical guys, we'll get to that later. Frank is a mechanical engineer, and we constantly go back and forth. So if you see him, you'll talk slow because he's a mechanical engineer. Here's some, real quick, some of the potential fields that you guys get into. This is by no means all-inclusive. Power, SCADA, power, the whole power industry. You know, we've got an aging infrastructure out there, the grid. These things are going to be needing to be upgraded and replaced, improved. SCADA is supervisory control and data acquisition. You know, you see all these substations out by the side of the road. It's not just a transformer and oil-filled circuit breakers. There's control equipment in there that will allow them to shed load remotely. They can open up circuit breakers. You know, there is power factor correcting capacitor stations that are out there that they'll bring banks in, and it's all done remotely. That's something that there's a lot of programming behind. There's a lot of programming out there. Almost everything that's either in terms of automation, PLCs, HMIs. That's the PLCs. You guys had one class in there, right? Okay, HMI is the human machine interface. That's that's your ATM. That all gets programmed. Robotics. Even if you want to do software, C, C++. R&D could be a potential field that you might want to look into. Problem with that is you have to watch your funding could get cut. You're not really making money, you're just doing product development. They could pull the plug on the project. So there's a little bit of risk associated with that. Manufacturing, I talked about that, controls and automation. There's a huge industry out there for electrical engineers. Military aerospace, I've done those gigs, they're okay. If you don't mind things not progressing very quickly, that's a good field for you to be in. Communications, I listed broadcasting up there. That's still, I guess people still do listen to the radio, but you've got this whole industry of smart devices, GPSs, those kind of things that need an electrical engineer. Law, as much as I'd hate to encourage the birth of another lawyer, I do have two good friends that actually went on to become patent engineers, or patent attorneys, and they have an engineering background, so engineering could be a stepping stone for that, as well as medicine. Politics, Jimmy Carter, you guys remember him? He was the father of the 14% inflation rate or something like that. He actually went to Georgia Tech, but he dropped out to go to the Naval Academy. I guess it was too hard. Insurance, one of our students that I went to attended school, I'm not suggesting selling insurance or anything like that. There's companies out there like Factory Mutual that will actually insure your plant and your production from any kind of damage, hurricanes, lightning, tornadoes, those kind of things, boiler inspection. There's you need an engineering background for that. Education, I'm sure most of your professors were electrical engineering at one time. And I found a slide, Bureau of Labor Statistics of where we are. The dark green that's where we are, and that's where there is a heavy concentration of electrical engineers. Okay, so you can see right here that the pointer, electrical engineers right here, 25% of the electrical engineers are over 55 years old. So you're entering a field where maybe there's going to be a shortage of these guys through attrition within the next 10 to 15 years. I tried to find one of these for electrical engineers that were 80 years old and over, but I think Dr. Pansino was the only one who was qualified. And I don't think, not yet. I think they're going to make a slide for him. Okay, here's some good advice from your old buddy Mike. These are some of the mistakes that I've made. Good communication, it's key. It's key. That's business and personal. You've got to have good communication. That's, Frank, we talk about that. This is the crux of every issue in life is based on communication and understanding one another. Organization, please be organized. It does show. I've got a couple guys. One of my guys he's a slob. He's got stuff everywhere, and I think it reflects in his work. So if you're organized, it's a good habit to have some discipline. Urgency, Yes, not so fast that you're making mistakes, but when you get out there, it's nice to have employees that get their stuff done on time. You don't want to be hounded by your boss. Are you done yet? Are you done yet? Back to the statement, assume it's due tomorrow. You want to be thorough in everything you do. I'm not talking about 12 decimal places, but just make sure that in your assignment that in your project that you're given at work, that you are thorough enough to consider all the different aspects related to that. Professionalism, that's where I've struggled with the most. It's just good practice to be professional. You're going to have to deal with customers, vendors, coworkers. It's always best to take the higher road and be professional. Promptness, if you're not 5 minutes early, you're late. And don't be walking out the door at 4 o'clock, because we've got some guys that do that, and it shows. Loyalty is something that has kind of gone away with 401ks and this digital age that we're living in. It's good as a hiring manager. It's really good to know that my guys are very loyal, and I don't have to worry about them being a flight risk. Go the extra mile. That doesn't hurt anything at all. My guys that do that are very well appreciated, and it definitely shows in their work. Be a sponge. Again, not everything is electrical. It does not hurt to ask questions. I mean, you guys, in some of your projects over there, you can see that it's just not everything electrical. If there's a senior guy or there's a mechanical guy, just ask. Definitely want to be a team player. Dr. Jalali talked about that. It's, you're always going to be on a team. You're always going to be working with coworkers. You're going to be depending on other people. They're going to be depending on you. There's no I in team, like they say, and where's Bob? There's no team in paycheck. Thank you for that little phrase. So you're in control of your future, but you're going to have to do it with the team. And you've got to have a positive attitude. That's another thing Frank and I talk about. It's imperative. Nobody likes a negative Nancy. These people rise to the surface very quickly, and they're not as valuable as the people with the can-do attitudes. It's like, I don't know, how are we going to do this? I don't know, but we'll figure it out. All right, I'm winding it down. I'm only 5 minutes late. I brought this in from last time. Has anyone seen Bill Gates' 10 Rules for Life? Good. Life's not fair. Get used to it. Enough said. The world won't care about your self-esteem. They'll expect you to accomplish something before you feel good about yourself. Coming from Bill Gates. Do not make this as a little bit. Do not make $40,000 a year right out of high school. Enough said. You understand that. If you think your teaching stuff will you get a boss, I can attest to that. Flipping burgers is not beneath your dignity. It's a yes. I don't need to read all that to you. Number 6, if you mess up, it's not your parents' fault, so don't whine about it. Okay, everybody's going to make a mistake. I made a couple. I made more than that. I'm just admitting to a couple. You have to own your mistakes. There's nothing wrong with owning your mistake. I think you're a better person for that, and I think the problem is resolved a little bit quicker once you do take ownership. This one, I don't know if it applies to anything here, but you guys can read it if you want. Yes. School may have done away with winners and losers, but life is not. Okay. Yeah, unfortunately, we live in a society and culture right now where it's everybody gets a trophy day. And when I was going to school, if you finished first place or second place, you basically were the first loser. And it's still that way when you get out into industry. They're kind of fooling you with our new culture right now, our new society. It can be competitive. In fact, it is competitive. This is the one that I kind of beat home. Life is not divided into semesters. I kind of wish it was, but I've been asking for summers off and nothing. Television is not real. Life is real, and sometimes it's not fun. It's not that good. So Bill Gates, he invented a computer or something like that. He's got a list of 10 rules, but there's number 11. Be nice to nerds. There's a good chance you'll be working for one. Yeah, I chuckled too, and it's like that was very endearing to hear somebody say that, especially Bill Gates. you know, you guys, electrical engineers, you're probably going to be terribly misunderstood in life, and I know I am. Sometimes you might feel like a necessary evil. It's okay. It's okay because, you know, we're the ones that understand what the square root of -1 is. So the next time you get people that are just kind of not really understanding, you can just sit back and smile and nod and know that you're a nerd. So that is all I have. Doubt if there's any questions. You guys are still nervous, aren't you? Relax. This will be all over today.
I add one more sentence to them.
Okay.
George W. Bush said, if you graduate 2.0 from your college, still can be a president.
Very true.
That was the exact word that he said in one of the commencements.
Awesome. Well, I only went 8 minutes over, so thank you very much.
Thank you.
You got it.